Welcome to this explainer. Right now, we're unpacking a massive tectonic shift happening in IT. We are rapidly moving from a world of isolated, static tools to a hyper-connected, truly autonomous tech ecosystem. If you've been paying attention to the industry lately, you already know that 2026 isn't just another year on the calendar. It's shaping up to be the absolute critical pivot point for how enterprise value is created and, honestly, how it's protected. Okay, let's just dive right into our roadmap for today. We'll be looking at the 2026 tech tectonic shift, the age of agentic AI, quantum error correction breakthroughs, 6G and integrated sensing, and finally, the future tech workforce. Section 1. The 2026 tech tectonic shift, moving from a digital base to an autonomous vanguard. To start us off, we really have to recognize that 2026 represents a foundational pivot in how technology operates globally. But before we get into the heavy technical architecture, we need to address the elephant in the room. We need to talk about human jobs. And look, I know there's immediate panic when we talk about this intelligent age, but look at this staggering number. The World Economic Forum projects 78 million net new global jobs by 2030. Yes, the rise in automation means an estimated 92 million jobs will be displaced, but get this, a massive 170 million new opportunities are going to emerge. The whole narrative that AI is simply a job killer completely misses the broader macroeconomic reality of things like the green transition and technological innovation driving historic employment growth. This brilliantly illustrates how the evolving tech landscape fits right into Gartner's 2026 pillars. It's kind of like a giant puzzle. Think of modern organizations acting in three distinct roles. First, as the architect, building secure foundations through AI-native development using prompt-driven code generation and agent-led compilation. Second, you have the synthesist, orchestrating intelligent multi-agent systems that combine AI and physical operations using these really seamless collaborative handoffs. And third, the vanguard, protecting value through preemptive cybersecurity that anticipates threats and defends at absolute machine speed. Moving to Section 2, the age of agentic AI, the software brain evolving from assistant to collaborator. Let's transition into the brain of this ecosystem. This is where the economics of software development are being completely reshaped. We're moving away from AI as just a helpful little assistant that writes a quick script for you to AI as a deeply collaborative, long-running partner. Now, what's really fascinating here is the paradigm shift from single-agent workflows to multi-agent systems. We used to rely on single agents doing sequential, minute-long, discrete tasks. But now, in 2026, we're unlocking multi-agent systems. This means parallel reasoning. It means coordinated, specialized teams of agents working autonomously for days or even weeks straight without needing a single coffee break. I mean, logistics companies using these systems have reported cutting the time to fully staff a massive fulfillment center from weeks down to under 72 hours. That's wild. So the crucial takeaway here, developers aren't just implementers anymore. They're becoming orchestrators. AI agents are handling all the messy reality of software development. The testing, the debugging, the documenting. Timelines are literally collapsing. In one Anthropic case study, Augment Code helped finish a 4-month infrastructure project in just 2 weeks. 2 weeks. And it's democratizing tech too. Imagine a marketing expert without any traditional coding background building out a highly complex, multi-channel campaign entirely on their own, just by orchestrating a team of specialized agents. All right, Section 3, quantum error correction breakthroughs, the hardware muscle crossing the fault tolerance threshold. So, if agentic AI is the brain coming up with solutions, we need some serious muscle to process those previously impossible calculations, right? And that brings us to quantum computing. For years, everybody was just chasing raw physical qubit numbers. You'd see these big headlines boasting about 1,000-qubit processors. But honestly, physical qubits are incredibly noisy and short-lived. The true metric for what we call the late NISQ or NISQ era in 2026 is the stable error-corrected logical qubit. This is constructed by combining multiple physical qubits into a structured code that allows for actual practical utility without losing its delicate quantum state. And this is where quantum error correction, or QEC, comes in. Because of the weird rules of quantum mechanics, you literally can't just copy an unknown quantum state to back it up. It's called the no-cloning theorem. So QEC encodes one logical qubit into many physical ones, running continuous checks to detect and correct errors without actually measuring and ruining the encoded information. Think of it like a choir. If one singer accidentally hits the wrong note, that's a physical error. The collective harmony of the group, the logical qubit, ensures the overall song isn't ruined. This is the vital breakthrough that gets us from theoretical promise to commercial reality. Let's see how this builds out in the real world. Looking at Quera's hardware roadmap, we can see exactly how this error correction scales. It starts from 10 logical qubits in 2024. Then, by 2025, using techniques with totally sci-fi names like magic state distillation, we hit 30 logical qubits. And finally, a projected 100 logical qubits backed by over 10,000 physical ones by the end of 2026. Once we hit that 100 logical qubit threshold, we are finally pushing computing past the absolute limits of what classical supercomputers can even simulate. Section 4. 6G and Integrated Sensing, the nervous system of the 2030 infrastructure. Okay, we've got a smarter brain, stronger muscle. Now we need a much faster, more capable nervous system. That brings us to the future of wireless networks with 6G, and we are looking way beyond just faster download speeds for your smartphone here. The standards timeline is officially locked. Following the June 2026 plenary of the 3GPP in Singapore, we have a clear, straight path to early 2029 for final 6G specifications. We'll see Stage 1 freeze in 2027, architecture design locked in 2028, and a final freeze by early 2029. This timeline is a massive deal. It acts as a rock-solid anchor for enterprise planning. It means hardware makers and network operators can start pouring billions into development right now, with total confidence in those target dates. A foundational game changer for this 6G standard is ISAC, Integrated Sensing and Communication. Historically, sending data and scanning the environment required totally different hardware and frequencies. ISAC essentially amalgamates data transmission and environmental sensing, like radar, into a unified front end, using the exact same waveform. It literally turns the cellular network itself into a giant spatial sensor. Just look at this quote from J.D. Griffith at the NextG Alliance. ISAC presents a revolutionary spatial sensing capability offered at an unprecedented scale. Think about what this actually means. Without needing dedicated, separate environmental hardware, mobile networks will be able to track drone fleets in real time, map highly dynamic environments, and monitor physical infrastructure just by analyzing how the network waves bounce off objects. It's incredible. Section 5. The Future Tech Workforce. The human heart orchestrating the intelligent age. Finally, let's look at the heart of this convergence anatomy. How do human workers actually fit into this hyper-connected 2026 landscape? We have agentic AI, error-corrected quantum machines, networks that can sense their environments. So, where do we fit in? Well, let me hit you with this stat. Despite all the AI anxiety out there, the tech workforce remains incredibly robust. It's projected to grow twice as fast as the overall U.S. economy over the next decade. And it's anchored by a highly lucrative median wage of nearly $113,000. The jobs aren't vanishing, folks. They are just evolving. And the premium on deep tech literacy is higher than it's ever been. But check out this massive 81% chunk right here. The criteria for landing these lucrative roles is completely flipping. 81% of employers from 2025 to 2030 are now prioritizing practical skills and experience over formal, traditional degrees. The sheer speed of technological change means a 4-year degree can literally be outdated by the time you graduate. Employers just want to know, can you orchestrate these new systems today? Furthermore, 77% of global employers are actively investing in internal upskilling. They know they can't just fire their way to a new workforce. The skills gap is way too massive for that. Organizations are aggressively building out internal training programs to bridge the digital divide. They're actively training their staff to become the architects, the synthesists, and the vanguards we talked about at the very beginning of this explainer. So the crucial point I want to leave you with in this explainer is this. The nature of work is fundamentally changing. In a world where technology is the ultimate implementer, it's writing the code, checking the errors, sensing the environment, how will you evolve? How are you preparing right now to step out of the tactical weeds and become the human orchestrator of this new intelligent age? Take some time to think about that one. Thanks for joining me, and we'll see you in the next explainer.